Oh, why? I'm sitting here. I'm sitting here doing nothing. So. Where? Ah. I saw that. I went there. Oh,
Yeah, just like making sure that you're on the right thing.
before even the meeting started?
How are you, sir?
I'm good.
Good.
How are you?
Not too bad. Ready to get started.
Hey, I was just thinking about that.
It's Tuesday already. Can't be unexpected to stay a week already. It's craziness.
I know. Tell me about it.
Okay, well, we should probably get started as it's, where'd Jeff go? I'll try to do this. Jeff, we should probably, yep. Folks, it's about that time. This is IDR second session. If you think it's some mysterious transport working group or some other routing group, probably you want to go someplace else, but it's IDR. You're doing the,
I can work through the notes.
okay. There's the, good.
Okay. So thank you, everybody. So a reminder, we have no blue sheets. Please scan the QR code. We have a nice giant room, which we need less than our first session, but please, we'd like to be able to get it next round. So take a picture. There's also a piece of paper going around with the QR code if you find issues focusing. So we're going to hit the reminders from exactly like every other IETF session. We do have this note well statement that provides a nice summary of the rules that you're engaging IETF with. This covers things from intellectual property declarations down to code of conduct. In general, be nice to each other. Even if you have controversial opinions, don't be a dick. So, meeting tips, if any of you are actually online, this is the ability for you to actually access via the data tracker for the agenda. Those of you that are in room that have taken a picture of the QR code, you're going to get dropped to a little micro app. Please use the stepping queue option before you go to the microphone. We want to make sure that people are actually answered in their order that they are, whether they're online or offline. Here's a pointer to the general IETF agenda and a pointer to how to file issues if we get there. We're going to fast forward through the working group status since this was all given last session. So for Tuesday, we're going to be covering about an hour's worth of subjects, and we're going to try to actually move through things at speed. We have a mix of things that are related to flow spec, labels, a little bit of BGP LS. We're going to be having a discussion about BGP attribute escape, and we're also going to have a presentation from our friends over at SavNet discussing the general problem space they're solving for source address validation, and they're at the beginning of their position to start discussing the protocol solutions. Not necessarily IDR's usual thing, but as somebody who's paying attention to a broad series of technologies, I do strongly suggest your attention for this because this is impactful.
Implementation. You're going to do implementation feedback on the number of implementations. No, not on SAPnet, on as a next topic. I'll do it. That's okay. Folks, Ketan and some other people mentioned to me about some confusions on implementation reports. If you have confusion or if you have questions or if you want to make comments, the chairs are listening. Come capture me after the meeting and I'll be glad to talk to you about it. Otherwise, we'll sort of keep this out of the meeting. Please, if you do have questions, come see me. And Ketan, if I've missed anything, please let me know, okay? Good. So we're at secondary label. I need an agenda. I got it.
Full label specifications.
That's right one. Yep, got it. Is Quan? Quan, are you online? Quan, are you online or in the?
Yes, Susan. Thank you. Can you hear me?
We can hear you fine.
Okay, thank you.
Please go ahead.
This is Chuan from. Okay, thank you. This is Chuan from ZTE, and my presentation is PGP flow specification for the flat flow mapping. Last slide, please. Thank you. This is the update from last versions, and has been presented at IETF 112 and 113. And we got some feedback from DATLAT and the IDR working group. Thank you for the comments from Luberger and Jeffrey Hunt. And based on their comments, we changed the draft name to clarify the TS mapping. So the title for our draft now is the BGP flow specification for DATLAT and the flow mapping. We also align with the progress of enhanced DATLAT data plane in DATLAT working group. We consider the new DATLAT specific metadata in scaling network requirements. We also changed the extensions from BGPFS version 1 to BGPFS version 2. In details, we added TSN sub-TLV to filter TSN streams. We also added deterministic latency action sub-TLV to accept the TSN streams and map them to the flat flows. We added DATLAT sub-TLV to filter DATLAT flows with deterministic latency information in enhanced DATLAT, such as QE metadata. Finally, we add TSN action sub-TLV to accept the DATLAT flows to and map them to the particular TSN streams. Next slide, please. So let's recap with the TSN and DATLAT mapping. As defined in RFC 86555, DATLAT provide the deterministic service for TSN, and DATLAT flows may be carried over TSN subnetworks as the figure shows. And so, as discussed in the DATLAT data plane, the requirements of control plane for TSN and DATLAT should provide DATLAT flow mapping. The mapping between TSN streams and the DATLAT flows is required for services proxy function at DATLAT end nodes, and the mapping table can be configured and maintained in control plane. So this document propose extensions for TSN and mapping and DATLAT mapping to achieve the end-to-end deterministic service. Next slide, please. So for the BGPFS extensions, First, for TSN stream mapping to datalet flow, we proposed the filtering rules for TSN streams. First, we proposed a new TSN sub-TLV based on the H802, the identification for the string and the function. So we based on the identification, we proposed the TSN traffic filtering in mask and match string identification. Like as the figure show, we proposed the MAC surface data unique to filter the TSN strings, and then we proposed the deterministic latency action sub-TLV to accept the TSN streams and map the streams to the datalet flows with a particular queuing mechanism to guarantee the latency. For example, we may accept the TSN streams to map the streams to the particular cycle ID or cycle size and the queuing with the queuing metadata. Next slide, please. So for the BGP FS extension for datalet flow mapping to TSN stream, we also proposed the filtering rules for datalet flows, datalet sub-TLV for the datalet traffic and filtering flow spec to filter the datalet flows with deterministic latency information in enhanced datalet, such as the queuing metadata. The metadata has been discussed in the design team in datalet working group. And then we also proposed the TSN action sub-TLV to accept the datalet flows and map the flows to the TSN streams indicated by TSN profile. As the figure shows, the profile may be converted or indicated to the string related parameters. Example such as the TSN string ID, string handle, sequence number, or the other traffic scheduling information. Next slide, please. So this is words of the BGPFS extensions for the datalet and the TSN mapping. Next step, we will continue to align with the BGPFS version 2 and align with the progress of enhanced datalet data plane in datalet working group. So we would like to get some feedback from the two working groups. Thank you, and comments and discussions are very welcome.
Any comments from the current audience? Remote or local? Thank you very much. We'll go on to the next presentation. Secondary legal, right? Yep, I do. Got it on this one. Satya?
Hi, Sue. Are you able to hear me?
Yes, Satya, we can hear you.
We can hear you.
Hey, thank you. Good evening, everybody at San Francisco. So I have my co-author with me, Praveen, and he can go through a quick introduction to the problem, and then I can explain the rest.
Okay, thank you, Satya. Hi, folks. This is Praveen Ramadenu from AT&T. And this proposal is for BGP secondary label and a couple of use cases that can benefit from better convergence with the use of this label. Can you please go to the next slide, please? So as we have various label modes for BGP labels, it can be per prefix, per VRF, or per CE, or in the case of the default VRF, we can have per next hop received label. And the benefit of the per next hop received label is it can help save the label scale on a given PE device or ASPR. So in our topology, we prefer to use this third option, which is the per next hop received label. And when this mode is used, it does save the label space, but in conjunction with this, we would like to achieve better convergence. So we use BGP PIC, prefix independent convergence. And the combination of these two features can result in some label churn issues, and that's what we would like to explain in the subsequent slides. Next slide, please. Thank you. So as you see on this slide, we have a group of 4 devices, and PE1 and PE2 are the provider edge devices, and we have the route reflector devices in the middle. So these devices are acting as a route reflector to receive the routes from PE1 and advertise them to PE2. And between RR1 and 2, they advertise the routes to each other as well. And in this topology, the initial state, a VPN prefix from PE1 is advertised to both RR1 and RR2 with a label of 100. And RR1 assigns a local label of 200, and RR2 assigns a local label 300, as you see here. And these routes are advertised to the PE2 as seen here with label 200 and 300. So until here, there is no issue, but the issue surfaces when RR1 advertises its routes to RR2 and vice versa. So once that is done, the tuple for this particular, or the context for this particular label is next hop and the received label. So in the case of RR1, the next hop is going to be RR2 and the received label of 300. So once this happens, subsequent label assignment occurs for on RR1 and RR2, which is shown in the next slide. Can you please go to the next slide? Yeah, thank you. So here, as you see, the local label changed from 200 to 201 on RR1, and correspondingly on RR2, it changed from 300 to 301. And this change is because, as we mentioned previously, the context is the next hop and received label. So in this case, on RR1, it will see PE1 with the label 100 and RR2 with the label 300. And on RR2, it will see PE1 as the primary path and RR1 as the secondary path. But then there will be continuous churn because RR1 will assign yet another local label. So the 201 becomes 202 and so on. So it results in a continuous label churn. And this label churn can exhaust the label scale on a given router. And the solution is to prevent this label churn and at the same time improve the convergence. So Satya will explain how this can be resolved with the secondary label concept. Thank you.
Thanks, Praveen. Thank you. Next slide, please. Yeah. So if we condense what Praveen just described, the local label allocation on a PE or RR is dependent on the received label that it received from the other, and vice versa. There is a mutual dependency. This is leading to the label churn, right? So to solve this, we tried various approaches. Like we were trying to give a timer-based approach in which will keep the labels invariant and expect that all prefixes with changed received labels within that arrive within the time. But we quickly kind of found out that that's not the optimal thing. So it would go over multiple iterations before that would converge. So the idea here is what we are trying to do is we have a secondary label which is based only on the primary path. In this case, the path from P1. I will explain with reference to paths because it's easier for me rather than back to the net. So what happens is the secondary label is based only on the path, or and the next hop and the secondary label in case the secondary label came along with the path, right? So so what will happen is, since the label context or the context for local label allocation now depends on the secondary label instead of the received label, if the secondary label exists in the update, then you can see straight away that it really doesn't matter what is the local label at the other node, right? That's why this loop will cease to exist after one or two iterations. So here I will not go through the solution walkthrough of 1 to 3 that is shown here, that was shown in slide 3 previously, but this is the initial state. So can we go to the next slide, please? So you can see that we started with, so the label coming from P1 is invariant, that is at 100. And the initial label, local label in the previous slide was 200, okay, on P1, rather on P0. And similarly on P3, it was 300. Now, because P0 and P3 received the update from each other, now their label context is based on the tuple, which is the primary path and the backup path. And the backup path for RR2 is the label 200, and the it was initially 200, and then he sends the secondary label, right, which is the same label what was before, because that depends only on the primary path, right? So they will create local, so RR1 will create the local label 201, RR2 will create the local label 301, but the secondary label in each is still 200 and 300 respectively, and they will send to one another, right? In the next iteration, they will find that, okay, nothing changed from the secondary label perspective, so the loop will immediately stop. Okay. Can we go to the next slide, please? So this is another problem, kind of not related, but along the same concept. So here we have shown a topology in which the same route is being injected from C1 and C2, and the idea is to always prefer the C1 as an exit point, so long as it has connectivity to at least one of the P's, P1 and P2, right? So so here what we are saying is the P1 will send traffic to C1 as long as the P1 C1 link is up. If the link is broken, it goes to P2, and and then again from P2 it can go to C1. If that link is also broken from P2 to C1, then only it goes to C2. So can we go to the next slide, please?
Did I miss that?
So here so to accomplish this, we will allocate a primary label, which is our usual thing, what we do in the BGP best external, right? So we have, so there is little bit typo here. I'll explain. I wrote a mail to Ajay, but I didn't want to pester him because I already wrote another mail before. But the idea here is the primary label 100 on P1 is pointing to C1 as the primary path and P2 as the secondary path, as the backup, as the secondary path. And for the label 200, which is also allocated on P1, the primary path is actually C1, and the backup path is the C2, which is the tertiary path. I got it
You need to,
reverse here.
pardon me, you need to come to conclusion fairly quickly. Thank you.
Okay, I'll take 1 minute to, thanks for that. So if traffic comes with label 100 from the left side, it goes to C1 so long as nothing breaks. If that link is broken, then the traffic is diverted to P2, and the label that is imposed on the traffic going from P1 is P2 is actually the secondary label that P2 sends to P1, and that is 400. And that 400 has primary path as C1 and backup as C2. So traffic will come to P2, and if there is no failure, it will go to C1. Now, if that fails, then P2's traffic will be diverted to C2, which is what we want. So next slide, please. So to do this, we conceptualized that we need a new optional transitive attribute, and the propagation of all that can be done by knobs that we have not shown here. And for this, we'll need an IANA assignment for the Attr code. And it's useful to put the type field saying, because this secondary label thing can be used in any context. So just to know under which context it can be used. So we put a type 1 field and then the corresponding label. And that concludes our talk. And we received a mail from IANA assignment regarding proper procedures for this. So we'll be engaging in that. So any questions? Thank you.
All right. This is K.U. Patel from Arcus. I'm speaking as a working group member with my working group chair hat off.
Kevr, it is coming garbled to me.
Well, at least you got my name right. So let me ask a question and make a comment. The comment is that if you're going to have an attribute, you probably want to think about a common encapsulation and not define a new attribute. And I can send some suggestions on IDR mailing list for that. But ideally, if you can avoid the new optional transitive attribute that you've defined is or trying to define would be great. The second thing is, and it's a question for you, is that this problem that you see particularly manifesting on RR is because you are trying to coexist RR on a forwarding router with next hop self and per se resiliency label that you want to bind particularly. So my question is, if you change the label allocation mode, does the problem still happen or go away?
So it's a good question. So this will happen with this particular label allocation mode. And just to refine on what you said, it's not only RR with next of self, it could be an option BSBR back to back.
Yeah, so my suggestion is don't use that allocation method.
Kevr, I'm not able to hear you.
Okay, we're going to go to the next presentation. Mei Ling.
Hello, Susan. Can you hear me?
We can hear you. Please speak a little louder.
Okay, thank you. This is a new chapter for the extensions of BTP LS to carry security capabilities. It's our
Mei
first
Ling?
presentation. Hello?
Mei Ling, you are very
Yeah.
quiet on our side. Could you speak louder or turn up the gain on your microphone?
Okay, it's better now?
Perfect, thank you.
Thank you. Okay, this is our first presentation in the IDEA workgroup. This new draft is for the extensions of BTP LS to carry the security capabilities. Next slide, thanks. Let's start with the progress we have made for the security services. Our China Mobile has many regions. Each region is responsible for purchasing and deploying the security equipment independently. So it's the lack the visibility across the multiple regions and it's difficult to coordinate globally. So to satisfy security requirement for end-to-end service, it's necessary to know the capabilities of all security devices in all the regions. But offline coordination is difficult as each region deployment status is dynamic. So it's important to have interoperable solutions because we purchase equipment from many vendors And with standard, we can easily enforce vendors to provide exposure function during our evaluation process. Next slide, thanks. So security function capabilities explosion is the combination of security and the network. It's the both requirement from carriers and also from the users. So to implement security functions capability exposure at the protocol level, some extensions of the existing protocols are needed, including collect security information from nodes, and such as distribute security ports, where protocols. Next, and this draft is how to get node security capabilities through the protocol BGP-LS, which defined in RFC 7752. We want this protocol to carry the security capabilities of the node. So we use the extensions. As we all know, there are three types of BGP-LS divided in the RFC: node, link, and the prefix. In different scenarios, these three types have different functions. So if we want carrying the security capability of the local node through the BGP-LS node, we would like to add a new node attribute here. We can see the picture in right in the table 4. We add a new node attribute TLV here. We defined it the new TLV code, which is 1030. The description of this code is for node security capability. When carrying the security capability of the remote node through the BGP-LS link, we also need to add a new link attribute. We add the new TLV code, which is 1099. And then the description for this code is link security information. Next. And the third is carrying the security capability of the AS through the BGP-LS prefix, then add a new prefix attribute, which we define here is 1148. The description is for the AS security capabilities. Next, as we are for the first time to give the presentations in this workgroup, we want more comments, feedback, reviews, and co-authors are welcome. And then there are also some appendix slides there. If anyone pay attention to this topic, we can discuss more details by the email list. Do you have any questions, Jeff? I see you hand up.
Yes, thank you. This is Jeff Haas. I have two comments for you. Comment number one is that this problem space is helpful. We see this also overlapping how to deploy FlowSpec in a network and covering, especially as we look at FlowSpec v2 and have different types of capabilities for filtering, we will need to figure out a way to have a mechanism for discovering this so it can be operated safely. So I'll offer comments to you on the list later on in that context. My second comment is it appears that you have many allocations from BGP-LS that I did a casual look at IANA, do not find IANA registrations for. If you do not have a allocation from IANA, you're requested in your draft to put in TBD, to be determined, so that people do not think that these are valid requests. That's my comments. Thank you.
Thank you.
Any other comments from the room or online? If not, we're going to the next presentation. Thank you, Mei-Ling.
Thank you, Susan.
Hello, everyone. This is my third version of this presentation that I've done across IETF. I apologize if you've heard this more than once. IEPG was one, the other one was GROW. I was giving those more in an operational context. This is more against IDR and procedures that we will want to follow. So this is a discussion about path attribute escape. We know that BGP is very successful because it's been easily to extend optional transitive path attributes and non-transitive attributes employed allow us to actually add things to the protocol without necessarily having to upgrade every router on the path if it doesn't need to understand the feature. So this has been a very successful thing for us. The problem we have is that sometimes these attributes get out into parts of the network that do not understand them, and enforcement mechanisms to filter them based on a feature are not able to be done because it touches routers that don't know what to do with them. I'm calling this attribute escape, and this is not so much like a prison break. This is more along the lines of somebody's let their dog off their lead and it's wandered away from you and is doing something bad to the neighbor's flowers. So why am I writing this document? We have multiple audiences for this in the operational community. This is to bring attention to this as an operational problem and the things that it can do badly. Here for IDR, this is a reminder that the protocol is very clear about how these features can actually work, but the consequences of following the procedures has not always been clear. So we're trying to actually have at least a place to talk about the problem and then decide what to do about this in terms of solutions we want to apply in the protocol. So we're very good about talking about individual path attributes and what they're expected to do, generally where they're expected to be done. We talk about filtering. We have become much more restrictive over the last several years in both IDR and BESS about talking about, does this attribute get away? And if so, what are the negative consequences? So we're looking for a way to start having that conversation in a more rigorous fashion. These things are all because BGP attributes are propagating according to optional transitive exactly as we'd like. So this is a happy thing, and occasionally non-transitive due to bugs. Minimally, we want to document what this condition is and then talk about the mitigations and then decide what we want to change in terms of procedure. A reminder for most of you who are actually working on BGP protocol implementations or specifications, why is this a problem? Well, imagine that you allow an attribute that has impact of some sort to get far away from where it belongs. So easy example of this might be a prefix SID, from SR LAN. This gets out of the network, eventually leaks into another network, gets associated with labeled unicast route, and now we're actually forwarding stuff based on prefix SID procedures, not intended as the provider would like to have it done. Tunneling caps is another example. Maybe a route leaks out with tunneling caps at some point due to some SD-WAN feature, and it gets into somebody else's network that knows how to understand things, and then they try to GRI tunnel all their traffic over to somebody 3 ASs over. This is probably not what they're intending. And some signaling information like our extended communities, this is especially a problem in BESS. Some of these communities get out of control, pop into weird contexts, and maybe it leaks back into a VPN network and causes improper VRF imports or something like that. The place that's most scary for us in terms of IDR and hard to articulate to the general BGP consumers is when it impacts route selection. You can end up with inconsistent route selection scenarios that cause black holes as the routes point to each other in unexpected ways. We also have the general problem of optional transitive nonsense. When we had the motivation to write the update to the BGP error handling procedures in RFC 7606, this was because of the adder set, attribute 128 that got out. We had two different flavors of the protocol field. It was literally a 2-byte AS versus 4-byte AS as that transitional period. And they would treat each other as bad updates. and knock over the adjacent sessions rather than, obviously it's not attached too far away. So this is a case where something leaked out of a VPN, was not properly enforced, got to something that actually was part of a VPN understanding feature, and it fell over and went boom. 7606 made our error handling such that things were more resilient. But that said, a lot of these situations really beg the question of why did this get so far in the first place, and why didn't we know that? Recent examples that we have in the operational community, the entropy label stuff as we've been going through IDR has been interesting, problematic. We specified that in 6790, and that feature had no tagging in it to prevent no escape or to detect that it happened. The authors, Creedy and John, very quickly realized this was a problem and very quickly put out 7447, said, do not do that. And well, that didn't stop our own company from screwing up and having an implementation that was in flight, sticking version 2 of the feature on the same code point. Yeah, we screwed up. We shouldn't have done that. John has put out basically an apology internet draft that explains the scenario, but that didn't stop somebody, there's a different vendor, getting asked by some very large customer, please implement entropy label, meaning interop with Juniper. They did the original 6790 feature, which, number one, we told you, don't do that. And number two, it hit the Juniper boxes, and again, incompatible features, sessions got falling over. Why did this happen? Because they implemented it and the attribute escaped, exactly as we were fearing. So, as much as we were bad implementers, we also are a victim of, the problem. Of course, the long-term fix of this that we're working on is the next top capability that has one of the mitigations we're going to be talking about as a thing we want to consider as general procedure in IDR. Second one causing us interesting headaches coming from Bestland is the DPath feature. The purpose of this feature is to provide for loop detection when you're transitioning a route from an EVPN domain to an IPVPN domain for the L3 VPNs, where you're losing AS path information as part of leakage procedures. As usual, you throw another leak detector on top of things, but again, this thing was incorrectly scoped. This means that if it hits an L3 VPN and then passes into internet, as an example, what happens if this thing is internet scoped, gets used? Well, a couple of bad things. Number one, this impacts route selection. You can end up with some routers in your IBGP domain selecting the path one way, some of them a different way. You have route loops. And even if you don't have route loops, this feature is intended to depreference routes that are actually being passed around. This means that if you are the owner of a very large network that has a DCI interconnect that's using this feature, it escapes into the internet, and you have a comparable route from somebody else that doesn't touch the DCI, your route is the worst possible route ever. You have intentionally lost money because you're not attracting traffic anymore. And clearly people think that's a business problem. So what this really is about, and we've had multiple conversations over the years about this class of problems, this is about scoping. We've tried to do this in different situations. Minimally, what we want to discuss is those common scoping criteria, build up a taxonomy of what we're looking to do, and then talk about the mitigations for them in the protocol and what we should recommend in our documents. AS scoping is the number one scoping that we use across most of BGP. Intra-AS as a scope is a thing. An important thing for this group to be mindful of is we just had a presentation about this one administrative domain feature session yesterday, which is intended to break the rules about what is an AS. We're going to have to think about these things in a more broad context. Some of the things are really scoped on next tops. If a next top change, you expect things to go away. The next top capability has this as part of our procedures. We've talked about this for other features as well. The situation dealing with consistent route selection is a really hard one. It really implies in most cases a flag day in some portion of your IBGP domain so that all the routers that are passing around this set of information can consistently converge. This is a tricky thing. We don't have clean mitigations for this, and we don't have a good problem description of it. And this is really critical because especially for a lot of these best related features, their operational assumptions are usually for a flatter network or less hierarchy in the route reflectors. They're impacted by this, and they don't seem to be aware of it. And this stuff is subtle. Part of the reason is we want to write this down so people know to watch for these problems. Even for boring things like communities, we have the old school 1997 communities. We've added large communities. cleanup of these things as a problem. Randy Bush has had excellent papers on this over the years. Thank you, Randy. We have RFC 7454 that discusses how to go about doing this stuff, cleanup at an operational level. In terms of protocol implementers, technically, the protocol has said all it needs to. This is more about vendors putting in good models to allow for better cleanup. And this is where, as protocol designers, we should be listening to people about doing these things. When we start interacting with the extended community features that are used for VPNs, we care about this one step more because cleanup is very tricky. So building profiles of where features actually are scoped to in terms of the families, providing easy modes for cleanup. These are all things we can do as implementers, but we also have to discuss the operational considerations of these things getting out. Other reason they have this conversation is sometimes it's not oops. Anything here that can cause a session to fall over due to crashes, inappropriate scoping, session resets, if you're not following full 7606 procedures for whatever reason, these are maliciously exploitable. And we have bad people on their internet we want to protect ourselves against. So this is a very important conversation from a security perspective. And this will be part of the conversation we take to the NOGs, is expanding this work, hopefully. In terms of mitigations of things we can do in the protocol, we have an interesting conundrum here. Explicit filtering of path attributes is one way to proceed with this stuff. The trouble is we know that BGP is successful because you can incrementally deploy new features without necessarily having flag days across the various providers. If we have people start taking security postures of filter everything except for that which is permitted, we have cut off new features. An example I gave Rudiger between sessions was, if we were to do the large BGP feature using an aggressive security stance, that feature would not have actually gotten deployed. And that's a very boring feature in the grand scheme of things, much less any of these more subtle things. So this is a conversation. Sometimes attribute filtering is safe for certain provider classes. If you're a stub AS, you know exactly what you're allowed to have. If you're some form of transit provider, you may want to filter for protective measures, but you're also potentially losing yourself money or customers because your routes being filtering something important may break a feature a customer is depending on in a transit fashion. So this is going to be a long conversation in terms of what we want to do in the protocol. Ben Madison offered an excellent suggestion in terms of thinking about things of, maybe as an example, we take our path attribute space, split it somewhere internally and say, some of these features have implicit scoping. Older implementations may not understand that. That's fine. But eventually you'll get to a range of places where this might actually be enforceable. Maybe it's a generic mitigation. This is part of the conversation we're looking to have. In particular, we're looking for smarter filtering technologies to be built into implementations, especially as part of profiles of features. We want easy modes to scrub things and make it safe on devices that are participating in the protocol mechanism, or devices that understand the protocol mechanism but are non-participants. As an example, an ASBR that understands EVPN knows how to scrub it, even if it's not going to participate in EVPN itself. So this is part of the discussion about what these profiles may look like from an operational standpoint, and also what we put in our documents. And of course, if we get around to doing BGP 5 or something like that, this is a chance to re-examine the conversation. Sounds a little bit silly, but we've talked about a attribute enhancement that puts scoping in there. It's an adopted work item. Not a single person has done it. So in terms of next steps, this is about socializing the ideas, making sure we actually can talk about things. Best needs to get a flavor of this presentation. We'll talk to them the next IETF. I'll probably go on roadshow at some point to discuss this in the operational community. What we're looking at is how to take this work forward, even if it's not necessarily my document. Let's talk about what the problem is, build a good problem statement, and let's actually start building mitigations, operational procedures, and potentially, is there something in the documents we should be doing normatively? We have security considerations, we have operational considerations. For BGP, maybe we need the considerations about attribute scoping. And once we actually figure out that's probably work that IDR will decide to take up.
We're about out of time, so I think.
So I'll happily discuss and take questions on this after the session. Thank you.
Nan, are you going to go ahead and present? If so, please go ahead.
Okay, thanks. Hello, I'm Nangang from Huawei Technology. Glad to give a presentation about the topic subnet architecture. Next, please. This presentation is about source address validation. It's an old topic. I think many of you know that, and some of you ever participate the discussion of subnet. Maybe I just want to give a brief introduction to the background to explain why we design a subnet architecture. Source address validation is important for blocking source address spoofed packets, and in the architecture drafts, we access subnet techniques are not in the discussion scope. We only focus on intra-domain and inter-domain subs, and they will help block spoofed packets. Next, please. Okay, there are many existing sub mechanisms like ACL and URPF like mechanisms. The common feature of the existing mechanisms are that they primarily generate sub rules based on routing information, like the information stored in FIB or RIB. In some cases, manual configuration are required. For example, we can configure ACL rules to blocking internal source addresses at border routers. Next, please. We do analysis on the existing sub mechanisms, and there are mainly two gaps. The first gap is there may be operational changes in dynamic or complex networks. One example is that we may need to update ACL configurations for accurate packet filtering. And second example is that the existing mechanism cannot work in all directions. So we need to figure out the application scenario. And gap two is inaccurate validation. Under asymmetric routing, the URPF like mechanisms, especially strict URPF, cannot work directly. Next, please. According to the gaps, we present two design goals for architecture. First is automatic update, and second is accurate validation. That is to avoid improper block and reduce improper permit. Our consideration is that routing information can be automatically updated, so goal one can be fulfilled by using routing information, but routing information is not enough for generating accurate subrules, like for example in the asymmetrical routing scenarios. So some information especially useful for sub but may not be useful for routing is needed to achieve the above two goals. Next, please. Okay, some delay on my side. Okay, thanks. So in this architecture, we define sub-specific information. Sub-specific information is represents any information indicates the accurate incoming directions of source addresses. Such information is specialized for sub. There are some examples of sub-specific information, like sub-rules. We can configure sub-rules directly, and topology information or forwarding information. Sub-specific information can be used to generate more accurate sub-rules than using routing information. So when we use the information, sub-specific information can replace or supplement routing information. And both sub-specific information and routing information are sub-related information. Next, please. Okay, the main idea of subnet architecture is to allow routers or ASs to advertise site-specific information. They can proactively advertise the local information to the neighbor devices or ASs or remote devices or ASs. The figure shows a simple example. Router 1 in existing some mechanisms, router 2 will receive routing information from router 1 and generate sub rules based on routing information. Such a process is automatic, but the results may not be accurate. And now, under this architecture, router 2 can receive site-specific information from router 1. Under this architecture, the sub-rules can be generated based on site-specific information, so the process is automatic and accurate. Next, please.
You should see it now.
Okay. The figure shows the architecture. There is a source entity and a validation entity. Source entity holds the sub-related information, and it will transmit the information to the validation entity. Validation entity will receive the information and generate sub-rules. Next, please. Sorry, there are some delay on my side. Okay, messages. We need some messages to carry the sub-related information. In our architecture, the messages can carry both sub-specific information or routing information. And there can be multiple sessions between source and validation speaker. We also give some descriptions in our drafts. Next, please. Oh, okay. Next, please.
You're on
We can have,
connectivity models.
yeah, connectivity models. We can have different connectivity models, and the combinations of the above are also supported. Next, please. Yeah, we have some use cases. Okay. We just introduced the first one. For example, we have two routers, and a subnet is multi-homed to the two routers. And under this architecture, the sub-specific information can be exchanged between the routers. Then we can solve the asymmetric routing problems somehow. Okay, next, please. And next, okay. There are also some use cases among ASs. So these ASs can also cooperate with each other. Next, please. More details can be found in the our drafts. We will also give a complete presentation in the subnet working group. Next, please. Okay, the above slides are about the architecture, and the following slides are more relevant to our IDR working group. So we are thinking about how to implement the architecture. Currently, the architecture is protocol independent. We do not define how to implement protocols in the drafts. So the question is, in the future, how do we design a new protocol or extend existing protocols to carry the newly defined information? Currently, because existing some mechanisms mainly depend on routing information. So extending routing protocols for carrying sub-specific information is the most intuitive method. So we consider to extend the routing protocols to carry such information. Next, please. Okay, so how about BGP extensions? We have some thoughts want to share in the working group. First, why BGP? BGP is widely used in many scenarios, especially among ASs. And the second is easy to extend and provide good service isolation because we can define new SAFE or SAFE. And third is we can reuse existing basic design and quality attributes. We can reduce the design and development workload. And finally, BGP can explicitly update the information, and we do not need periodical flooding. Okay, next please.
We're at the end of the session, so please wrap up.
Okay, it's concluded. Welcome to leave your comments in the mailing list. Thank you.
Thank you all. Thank you for joining us and running a few minutes late. Thank you again, Nan.
Awesome. 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 We have a lot of failing list follow-ups we need to do, but at the very least,
We got through it.
So do I. One more.
I'm going to meet with Gunther and Adam on Thursday morning to talk about what's like 8:30 to 9. Donald's going to be with me.
So if you can do anything to do, please see if I'm cross schedules.
Okay. You're welcome.